Welcome back, everyone. In this video, I will be going over the proof using the squeeze theorem to prove the special limit, the limit as x goes to 0 of sine of x over x equals 1. Now, really, we're going to use theta because we're going to be dealing with angles, but it's just a replacement for x. You can use x or theta in this formula, and it all works out. Now, the way this is going to work is it's going to be built on looking at a pi section of the unit circle. So the unit circle, I'm just going to just kind of fill out a circle to remind you. It has radius 1, which is why I have radius 1. And really, that's the most important thing. You do know that on the unit circle, the x value is cosine, the y value is sine on a point, and then tangents sine over cosine. But I'm going to get rid of that because I don't actually want that in the picture. What I do want is to now use each one of these pictures to make a formula. I'm going to make a formula that looks something like this. Now, it's not going to have anything really to do with these three things. I just want to say something is between something else. So let's go ahead and do it. So this first one here, what I'm going to do is make this into a triangle by taking this line and drawing it farther up until it drops straight down and makes a triangle right here. So we got a right triangle. And I want to write the area of this right triangle. You do want to remember that the area of a right triangle, the area of a triangle in general, is 1/2 times the base times the height. And the base is 1, so we got 1/2 times 1. Now, what is the height? Because this is the height here. Well, because the adjacent side to theta is 1, this is actually equal to tangent of theta. And if you want to check that, go ahead and set up an equation from this theta. What is tangent equal? It's opposite over adjacent. So if I just do it on the side a little bit here, if I do from this perspective, tangent of theta is opposite over adjacent, we get tangent of theta equals opposite side, which I claim to be tangent of theta, so we're just checking it, over adjacent side, which is 1. And does this work? Yes, tangent of theta definitely equals tangent of theta. So this is just tangent of theta, the height. And let's go ahead and just plug that in. Tangent of theta for the height. And this simplifies on down to tangent of theta over 2. All right, now the next one I'm not going to mess with at all. It's just the area of a sector of the circle. If you remember the formula for the area of a sector, it's 1/2 times theta times r squared. Now theta is just theta, but r is 1 because we're on the unit circle like I described before. So this is 1/2 times theta times 1 squared. This is 1, so we get theta over 2. And then the last one, I'm going to make another triangle here. And the triangle I'm going to make is going to be formed by this side and this side. So the two sides we're already dealing with, but I want to cut just like that and connect the other two sides to make a triangle. Now this isn't a right triangle, but what we can do is figure out the height. Why can we figure out the height? Because if we drop this straight down, we can make a right triangle. But the area is still the same idea. Area is 1/2 base times height. And the base is still 1. It's 1/2 times 1. But what is the height here? What is h? Well, if you look at just the right triangle here, we don't know the bottom side, but we do know the hypotenuse. The hypotenuse is 1. If you set up an equation, you get sine of theta. I'm using sine because I know I want opposite and hypotenuse. Sine is opposite, which is h, representing the height here so I don't get confused, over the hypotenuse, which is 1. And that's saying sine of theta equals h. I'm going to go ahead and now plug that in for h, sine of theta. And this simplifies to sine of theta over 2. Okay, that's great. Now, why does that help us? Well, what you want to notice is that this triangle is bigger than the sector, and this sector is bigger than this triangle. So what we just figured out is this inequality. This is the biggest one because it's the area of the big triangle, tangent of theta over 2. It's the biggest, so it's greater than or equal to the area of the middle one. The sector is just theta over 2, which is now greater than or equal to, and then the smallest triangle's area is sine of theta over 2. All right, so this, as it stands, doesn't really help us because we want to prove this. We need a sine of theta over theta in the middle, and we have nothing like that. Well, one thing you can go ahead and directly help yourself out with is if you have an inequality and all the denominators are the same number, which they are, can cancel them out. So we've got tangent of theta is greater than or equal to theta, which is greater than or equal to sine of theta. All right, and why is this going to help us? Well, I'm going to do something that's initially going to look strange. I know I want the inside to be sine of theta over theta. I'm going to first divide it by sine of theta. But if I do that, I must divide everything by sine of theta. Okay, so I'm dividing by sine of theta. Keep in mind, theta is not 0. Since theta is not 0, sine of theta is not 0, and I can do this. Then what do I have? Well, tangent of theta over sine of theta, you can simplify. Let's just do it very, very quickly. Tangent of theta equals sine of theta over cosine of theta. Now, if I want to divide this by sine of theta, I can think about it multiplying by 1 over sine of theta. So the sine of thetas cancel, and I get 1 over cosine of theta. So this is just 1 over cosine of theta is greater than or equal to theta over sine of theta, which is greater than or equal to sine of theta over theta is just 1. Right? Now, it's a little complicated as to why this one works, because sine of theta can be negative. But the thing is, you want to think about theta being close to 0. So it can be slightly negative or slightly positive. When tangent is negative, that's also when sine is negative. So when we divide a negative by a negative, whether it's this one and this one, this one and this one, this one and this one, the inequalities don't change. Okay. All right, now the very last step here, we've almost got sine of theta over theta in the middle. We have it flipped. You can do the reciprocal of every single part in an inequality as long as you reverse the way it's written. So we can reverse the way it's written. This would be cosine of theta if we do the reciprocal. The inequality gets reversed. Then we do the reciprocal there. We get sine of theta over theta. It gets flipped again, less than or equal to 1 over 1 is just 1. Right. And now why are we pretty much done? Well, what's the limit as theta goes to 0 of this? And what's the limit as theta goes to 0 of this? Okay. The limit as theta goes to 0 of cosine of theta. Well, we just plug in theta equals 0. Cosine of 0 is 1. What's the limit as theta goes to 0 of 1? Well, that's just a number, so it always gives us the 1. And the squeeze theorem tells us because the one we're interested in is between these two, and they have the same limit of 1, that means the limit as theta goes to 0 of sine of theta over theta must also be equal to 1. Okay. And once again, I know it's pretty complicated. A lot of stuff with inequalities that you may not be comfortable with. You don't have to know how to prove it. I just wanted to show you really how hard it is to prove this theorem. But the way we did it before with plugging in numbers to figure out a limit, that's not very mathematical. That's really never okay. It's just to give you an idea of what your answer is. This is how we would actually solidify that sine of theta over theta, the limit as theta goes to 0 equals 1. And so I hope you enjoyed that. If you did watch this, well, then you'd be hearing this right now, and I'll see you in the next video.